Yes, hello everyone. Welcome on Upedia platform. I hope you all are fine. Guys, I am Vishal Sharma and today I am here in front of you to cover very important topic, automobile air pollution, especially the air pollution caused by automobiles, IC engine, okay, petrol engine and diesel engine. So guys, we are going to cover this topic for upcoming examination. Junior engineer, the assistant environment engineer and junior environment engineer through Punjab Public Service Commission. Okay, so guys, let's start our today's discussion. So first we are going to discuss some basics. What is air pollution? Guys, if some kind of unwanted harmful substance is adding into the air which can cause some kind of what you can say deleterious effect on the life upon our planet, those are known as what? Air pollutants, and that is going to cause the air pollution. Okay, so any unwanted material, it may be kind of carbon monoxide which is entering, it may be NOx, it may be hydrocarbon. Okay, so some kind of pollutants which we are generating from IC engine or other kind of hydropower thermal power plant, okay, or some kind of fuel if you are burning at your home or at some industry, so that pollutant is going to enter into the air, which can cause some kind of harmful effects in the air because we are going to inhale that air. Naturally in air what is present? Mostly the nitrogens, close to 78% by volume, 21% by volume oxygen is there, and other gases like hydrogen, helium, those gases are also there, close to 1%. Okay, but yes, some other pollutants also we are adding when we are carrying out burning of majorly fossil fuels. Okay, so guys, the major sources of air pollutions are what? Electric power stations, majorly thermal power stations, construction areas, construction sites. Automobiles are also the major source of air pollution. Industrial and domestic fuel consumers, they are also the cause of air pollution. Internal combustion engine, guys, especially the petrol engine, diesel engine, they cause huge amount of air pollution, and we are going to focus especially on this pollution caused by IC engine. Okay, so guys, pollutants are what? Pollutants are the harmful substance which are generated from some source. Okay, source may be a automobile, source may be a industry, it may be a kind of thermal power station. So the place from where you are generating that harmful substance, that is known as the source of that pollutant. So based on that, we can classify the pollutant emission into two categories, the primary and the secondary. What are primary pollutant emission, guys? The primary pollutant emissions are the emissions caused by pollutants which are directly coming out from the source, like the hydrocarbon, carbon monoxide, nitrogen oxide and particulate matter. So these are the kind of pollutants which are directly coming out from the source, IC engine, or it may be a kind of thermal power station. But when they are entering into the atmosphere, guys, like hydrocarbon, carbon monoxide, nitrogen oxide, particulate matter, when they are entering into the atmosphere, they are reacting under some sunlight and they are causing some other detrimental effects like photochemical smoke or sulfurous smoke. Okay, so that is known as what? A kind of secondary pollutant emission. So primary pollutant emission is what? The emission caused by the pollutants directly coming out from the source, and when those further pollutants coming out into the air and further they are combining, they are reacting and they are further causing some kind of pollution, that is known as secondary pollutant emission. Okay, so this is a kind of brief categorization. Primary pollutant combustions emissions you can further classify into two categories, combustion and evaporative. So these both, primary means they are generating from the source, so combustion means these are the emission generated from the source when you are carrying out combustion of a fuel. Evaporative means you are not carrying out combustion, but even the hydrocarbon is evaporating, because if we will talk about petrol is a very volatile substance. So if petrol is there in the fuel tank, okay, petrol is there in the pipeline through which you are transferring the petrol from the tank to the carburetor or main engine part, so some kind of evaporative loss takes place, some kind of fuel evaporates, that is known as what? Evaporative pollutant emission. That is also going to cause pollution, guys, because the hydrocarbon, when it is entering into the air, it is going to cause some kind of detrimental effect. Okay, so guys, that's why we are categorizing these primary pollutant emission, the pollutant emission which is caused by directly from the source, combustion which is taking place due to the combustion of fuel like hydrocarbon, unburnt hydrocarbon. It will be right if you will say there is a difference between this hydrocarbon, the hydrocarbon which you are directly getting, which is a kind of evaporating from the tank or the pipeline. This is what? This is unburnt hydrocarbon. Okay, some kind of hydrocarbon which is not getting sufficient air inside the engine, and that's why it is coming like that only. It is not combusting. Okay, so you are carrying out the combustion, but it is not getting sufficient air. Okay, so that's why you are getting some hydrocarbon in the exhaust combustion product. So these are the pollutant emission which you are getting from the exhaust gases. Okay, this is not present in the exhaust gas. This is a kind of evaporative pollutant emission. Okay, carbon monoxide, nitrogen oxide and particulate matter. In detail we are going to discuss what are the reason actually behind this hydrocarbon, carbon monoxide, NOx and particulate matter emission, guys. Fine. Chaliye, let us move to the next slide. So guys, before that, let us first talk about the stoichiometric air fuel ratio, because to know why actually carbon monoxide is producing, why NOx is producing, why we are getting the unburnt hydrocarbon, you need to have some basic idea about this term, which is known as stoichiometric, or this is also known as chemically correct. Chemically correct air fuel ratio. Okay, chemically correct air fuel ratio. You can write it as like this also. Chemically correct air fuel ratio. So guys, the minimum air theoretically required, for the complete combustion of unit mass of a substance that represents the air fuel ratio. For example, let us take methane. Okay, let us take methane, CH4. So we want to find out the air fuel ratio, the stoichiometric air fuel ratio for methane. How much air is required for the complete combustion of 1 kg methane? That is known as stoichiometric air fuel ratio for methane. So guys, we are having methane. The chemical formula for methane is CH4. So if you want to carry out the complete combustion of this, means it requires some oxygen, because in the presence of oxygen only it is going to burn, and in the exhaust product you are going to get CO2 plus HO2. So water vapor, this is what water vapor. Okay, water vapor. So guys, when we are talking about the complete combustion, the minimum air required theoretically for the complete combustion of unit mass of a fuel, that is known as stoichiometric air fuel ratio. For example, we are taking a case of methane. So methane plus oxygen, you will get the product like this. So now this equation is balanced or not, guys? This is not a balanced equation. Why? Because here how many carbon? Carbon is 1, fine. How many oxygen? Oxygens are 3 here. How many hydrogen? Hydrogen are 4. So you need to make this equation balance. So let me take here hydrogen 4. So let me write it here 2. So now 2, 2, you will have 4 hydrogen, fine. So hydrogen balanced, carbon already balanced. How many oxygens? 2 and 2, 4. So you can write it here 2 more. So now you are having a balanced chemical reaction. आपके पास क्या है? Balanced chemical reaction. Guys, you know to carry out this analysis for all fuels, but you know to have some understanding what is that stoichiometric air fuel ratio. Because then only you will be able to understand that when we are providing a rich mixture, a mixture which is rich in fuel, which is not having sufficient air in it. So in that mixture, if you are transferring into the engine, obviously you will get the unburnt hydrocarbon. So unburnt hydrocarbon which we are getting in IC engine, whether it is a petrol or diesel, that will result if you are supplying some excess fuel. Are you getting? So before that, you need to understand the stoichiometric air fuel ratio, because based on that stoichiometric air fuel ratio only, we will be able to define the rich mixture and lean mixture. Okay, fine. So guys, now what we can write? What we can write it here? We can write it here 1 mole of methane requires, how many oxygen, guys? 2 moles of oxygen. 1 mole of methane require 2 mole of oxygen. You can check it here. This is 1 mole of methane. This is 2 mole of oxygen. You know guys, mass M is nothing but Nm, where this M is the mass in kg. Okay. This is what? Number of moles. Okay, and what is this? This is molecular weight. Molecular weight in kg per kilomole. Okay, similarly, this is what? This is kilomole. Fine. This is kilomole. Okay, so we are taking kilomole, or this is what? Molecular weight in kg per mole. Okay, or you can take it here mole. Then you will have here what? You will have here gram per mole. Fine. So 1 mole of methane requires 2 mole of oxygen. So if you want mass, अगर आपको mass चाहिए बच्चों, what you can write? You can write it here Nm. So N is what? 1. How much is the molecular weight of methane, guys? The molecular weight of methane, hydrogen is 4, 1. 1 into 4, you will have 4, and for carbon the molecular weight is, atomic weight is what? Atomic weight is 12. So 12 plus 4, the total molecular weight will be 16. So 16 kg, because 1 is the mole and the molecular weight is 16, so 16 kg methane requires 2 into, how much is the molecular weight of oxygen, guys? 2 are the number of moles, and how much is the molecular weight? For oxygen, the molecular weight is 32, 16 is the atomic weight for one oxygen, but here you are having O2, so molecular weight will be 32. Okay, so 2 into 32, 64 kg of oxygen. Fine, guys. So 16 kg methane requires 64 kg oxygen. So 1 kg methane requires 4 kg oxygen, guys. Are you getting idea, guys? So 1 kg methane requires 4 kg oxygen, but we don't want the oxygen, we want what? How much air is required for the complete combustion of 1 kg methane, 1 kg fuel. You know, guys, in air, 1 kg air contains 23% of what? Oxygen, mass basis. So 1 kg air contain 23% means 23 by 100 kg, what you can say, oxygen. Yes or no? 1 kg air contains this much kg oxygen. या आप इसको रिवर्स करके लिखोगे, so this much kg oxygen is there in this much kg air. So in 1 kg oxygen will be there in how much kg air, guys? 1 kg oxygen will be there in 100 by 23 kg oxygen air. Are you getting some idea, guys? Okay, so I'm writing in percentage, or if you write it like this, you can write it like this also. Let me write it like this, because 23%, so you can directly write it as 0.23. Okay, directly you can write it as 0.23. So 1 kg, if you want 1 kg air oxygen, so 1 kg oxygen is present in, this is what, this is 0.23, so this is present in 1 by 0.23 kg air. So this is the final. Okay, 1 kg oxygen is there in 1 by 0.23 kg air. So simply, guys, if you divide this by 0.23, so 1 kg methane requires 4 by 0.23 kg air. Are you getting, guys? Why actually I am dividing this by 0.23? Okay, so this is a reason why, because there is 23% oxygen is there in 1 kg air, means 23 by 100 kg oxygen is there in 1 kg air. So if you want 1 kg oxygen, so 1 kg oxygen is there in 1 by 0.23 kg air, but how much oxygen we want? We want 4 kg oxygen. So 4 kg oxygen will be there in what? 4 by 0.23 kg air. So 1 kg oxygen is there in 1 by 0.23 kg air, 4 kg oxygen will be there in 4 by 0.23 kg air. So if you carry out this calculation, you will get the number close to 17.3 kg air. Okay, so for the complete combustion of 1 kg methane, how much air is required? 17.3 kg air. That's why the stoichiometric air fuel ratio for methane will be what? The air fuel ratio stoichiometric for what? For methane. Methane के लिए stoichiometric air fuel ratio will be 17.3:1. Are you getting, guys? So are you getting some idea? This 17.3:1 represent stoichiometric air fuel ratio. Suppose you are providing a air fuel ratio of 20:1. It means the mixture is rich or lean? The mixture is lean. Lean means it is lean in what? Lean in fuel. So if a mixture is rich in fuel, that is known as a rich mixture, and if a mixture is a lean in fuel, that is known as a lean mixture. So if you are supplying excess air, 20:1, excess air you are supplying, that mixture is known as a lean mixture, and if you are supplying excess fuel, that mixture is known as rich mixture. So guys, if you are having a ratio something like 15:1 for methane, it means that is a rich mixture of methane. And if you are supplying a mixture of 20:1, it means that is a lean mixture. So suppose in some engine you are burning methane, for example, you are burning methane and you are supplying a air fuel ratio 14:1. It means you are supplying rich mixture. Rich mixture means that mixture is rich in fuel, less air you are supplying, 14:1. less air you are supplying, it means the chances of getting the unburnt hydrocarbon, the chance of getting the carbon monoxide, because the complete combustion is not going to take place because you are supplying less air. Okay, so carbon monoxide emission, the hydrocarbon emission is going to increase. That's why we discuss this very important particular topic thing, stoichiometric air fuel ratio. So I hope this topic is very much clear. What is that stoichiometric air fuel ratio and what you understand by rich mixture and lean mixture. So if you are having air fuel ratio 20:1, that is a lean mixture, and if you are having air fuel ratio 15:1, 14:1, 10:1, that is a rich mixture. Rich means rich in fuel, lean means lean in fuel. Okay, similarly you can just remember this air fuel ratio, stoichiometric air fuel ratio for petrol. Okay, petrol के लिए stoichiometric air fuel ratio is 14.7:1. Roughly we write it as 15:1 also. Similarly, the stoichiometric air fuel ratio for diesel fuel is close to 14.5:1. Okay, so for 1 kg of petrol, how much air is required, guys? 14.7 kg. Okay, similarly for 1 kg of diesel, how much air is required? 14.5 kg. So stoichiometric air fuel ratio for diesel is 14.5:1. Stoichiometric air fuel ratio for petrol is 14.7:1. Now let us move to next. Guys, pollutants, as we already discussed, what are the different pollutants we can observe in SI engine. These are hydrocarbon, these are carbon monoxide, this is NOx emission. Okay, further you can have some kind of smoke, particulate matter pollution also. Majorly particulate matter and smoke pollution we are going to get in case of diesel engine, because diesel is a kind of impure fuel as compared to petrol engine. Okay, so in general you can write it like this, or you can write it here particulate matter or smoke also. So guys, here I'm going to show you some kind of different pollutants and the effect of air fuel ratio. Okay, this is very important, guys. So just observe it here. Here we are taking what? Different pollutants like the carbon monoxide, hydrocarbon and NOx. Okay, let us talk about these three first. Okay, so carbon monoxide. So what is carbon monoxide, guys? Suppose you are burning some carbon and it is not getting sufficient air, for example. Okay, it is not getting sufficient air. So in product what you will get, guys? In product आपको क्या मिलेगा? Product में you will get carbon monoxide. Okay, product में you are going to get carbon monoxide if sufficient oxygen is not there. Okay, something like this. So let me write it here, 2CO. So this is 2CO. So if you balance this, here also you will get what? 2CO. So this is a kind of balanced chemical reaction. Are you getting, guys? So for 2 carbon atoms, you are supplying what? 1 mole of 2 mole of carbon, you are supplying 1 mole of oxygen only. So this kind of reaction you will get 2CO. Less air you are supplying. So guys, if less air is there, obviously it contains less oxygen, so you will have what? Carbon monoxide emission. That's why you can check it here. As if you talk about SI engine, petrol, so petrol के लिए how much is the stoichiometric air fuel ratio? So stoichiometric air fuel ratio for petrol is 14.7:1, or roughly you can write it as 15:1. So air fuel ratio for petrol, stoichiometric air fuel ratio for petrol is roughly close to 15:1. So you can check it here. So close to 15:1, the carbon monoxide emission is very less. And as you are going to increase the richness means you are supplying fuel 14:1, 13:1, 12:1. So as the richness is going to increase, the carbon monoxide emission is going to increase. So as the leanness is going to increase, here the leanness is increasing. Lean mixture is becoming lean. तो इधर क्या बढ़ रहा है? Leanness. इधर क्या बढ़ रहा है बच्चों? इधर richness, more fuel. Okay, so if more fuel is there, obviously that is required some time due to idling condition. Okay, due to cold starting condition. If you are starting an engine under some kind of, when you are initially starting the engine, that is known as cold starting, because the engine temperature is very low. So in that case, if you are supplying the stoichiometric air fuel ratio, you will not be able to carry out the combustion. So initially, for starting an engine under cold starting condition, we need to supply the rich mixture. Similarly, if your engine is standing, your vehicle is standing at some light point, Okay, you are standing at some light point, generally we say it is good to turn off your vehicle, and that is required. Why? Because if you are running your vehicle, if your petrol vehicle is standing at some light point and your engine is turned on, then obviously the rich mixture is required to sustain the combustion under no load condition. So under idling condition, no load condition, rich mixture is required in the engine. Okay, those are much more further technical thing. Why actually rich mixture is required? Okay, because some kind of charge dilution takes place in engine when your valve is almost closed, because accelerator is not on, throttle is almost closed. So in that case, if you are supplying the lean mixture, you will not be able to sustain the combustion. Your engine will automatically turn off. Okay, but yes, if you want to keep, mostly if you are keeping your engine on, it means we want to keep it on only. It is not like that, you are keeping your engine turn on and automatically it is turn off. Okay, that is not good actually, because that is going to cause some kind of discomfort for us. Okay, so if you are keeping engine on, it means we want to sustain the combustion, and if you want to sustain the combustion under no load condition, we need to supply the rich mixture. So that's why under some kind of no load condition, cold starting, if you want maximum power, you want acceleration, you want to, you know, a kind of you want to overtake some vehicle, in that case also acceleration, you want to supply the rich mixture. So rich mixture is required at various, you know, conditions in the IC engine. So during that, the carbon monoxide emission will be high, and as the leanness is going to increase, the carbon monoxide emission is going to increase. That's why we discussed that particular point. This particular line is representing stoichiometric air fuel ratio. So at stoichiometric air fuel ratio, the carbon monoxide emission is not zero, it will have some value. But further, if you are having, you know, slightly lean mixture, okay, slightly lean mix, slightly excess air if you are supplying, then carbon monoxide emission will be almost zero. Okay, but at stoichiometric it will not be zero, because theoretically we can say yes, we supplied sufficient air, but yes, in real case, if you are supplying just sufficient air, minimum sufficient air which is required for the complete combustion, that if you are supplying that in the engine, you will not get zero carbon monoxide emission. Obviously some carbon monoxide emission will be there, because each and every fuel particle is not going to get that air. But suppose if you are pumping some additional air inside the engine, then there are chances that each and every fuel particle will get sufficient air to carry out the complete combustion. So that's why at here, slightly lean at slightly lean mixture, the carbon monoxide emission will reach to the zero value. Similarly, you can check it here, the unburnt hydrocarbon emission also, here it is very high at rich mixture. With rich mixture, unburnt hydrocarbon emission is higher, and as the leanness is going to increase, it is going to decrease. But yes, it will have some value, because, you know, sometime it is not like that ki unburnt hydrocarbon emission is not going to remain. There are so many, you know, cases in the engine. Sometime when you are injecting the fuel, suppose you are not injecting it at high pressure, so some droplets are going to, you know, stay over the walls of the engine, and those droplets, suppose they are not getting the air, so obviously that fuel particle goes into the exhaust gases unburnt only. So that is known as unburnt hydrocarbon. Okay, so if some fuel is going into the exhaust gas without burning, that is known as unburnt hydrocarbon emission. You know guys, all fossil fuel like petrol, diesel, they are known as hydrocarbons. So if some unburnt fuel you are getting into the exhaust product, that is known as hydrocarbon emission. So hydrocarbon emission may be directly there in the exhaust product also, and hydrocarbon emission you can get due to the evaporative losses also, because evaporative losses can take place in the engine tank and in the other pipeline also. Okay, so you can check it here. One more thing guys, you need to understand here, the NOx emission, carbon, this nitrogen oxide. Okay, nitrogen oxide emission, oxides of nitrogen, which are known as NOx. Okay, so they will have the maximum value. NOx emission will be maximum with slightly lean mixture guys. You can check it here. With the lean mixture means NOx is what guys? NOx is the reaction, NOx, nitrous oxide you are going to get in the product when nitrogen is combining with the oxygen. So guys, nitrogen is there in the air and in huge amount. Okay, close to 78% nitrogen is there by volume in the air. So when that nitrogen is going to react with the oxygen, so when there will be oxygen inside the engine, when you are supplying it in excess. So if you are supplying very less oxygen, means you are supplying rich mixture which is rich in fuel, lean in air. So that is known as rich mixture. So a mixture which is rich in fuel, lean in air, so it will have very less oxygen with it. And if oxygen is lesser, there will be no nitrous oxide formation. So nitrous oxide formation will be lesser with the rich mixture. Nitrous oxide emission will be there with the slightly lean, but why not very lean guys? Why not very lean? Because nitrogen oxygen is required for making the nitrous oxide, and actually they combine at a very high temperature. So there are two conditions. One, the excess availability of the oxygen. Second, the high temperature. So if there is excess availability of oxygen and at the same time you are having very high temperature inside the engine, NOx formation is going to take place. So if you are able to reduce the engine temperature, if you are using lower compression ratio, the NOx emission is going to decrease. Petrol, diesel, the NOx emission is almost similar, but slightly higher NOx emission you can observe in diesel engine, because diesel engine, they operate at high compression ratio, okay, and due to that the temperature pressure is generally higher in diesel engine, so NOx formation is slightly more. Otherwise, if you talk about the hydrocarbon and carbon monoxide emission, so what do you think, guys? Carbon monoxide emission or hydrocarbon emission is higher in petrol or diesel? Generally student think ki sir diesel engines are they develop more pollutants as compared to petrol engine, but it is not like that, guys. Petrol engine, the carbon monoxide emission and the hydrocarbon emission is more in petrol engine. Why? One thing, petrol is more volatile, okay, it is easily going to evaporate, whereas diesel, if you are keeping them in some tank, the evaporative losses are very less, okay, because it is not a kind of volatile fuel as compared to petrol. So hydrocarbon, whether it is unburned hydrocarbon or whether it is the evaporative hydrocarbon, those emissions are lesser in diesel. Second thing, in diesel, you know, guys, we supply excess air. We use some kind of turbocharged diesel engine, TDI technology. So some kind of turbocharging we carry out in diesel engine, so that we will be able to supply some excess air in diesel engine. So in diesel engine, always we supply excess air, and in diesel engine the suction of air only takes place. The injection of fuel we carry out at the end of the compression stroke. So when only suction of the air is taking place, huge amount of air will be able to enter into the suction stroke, into the combustion cylinder. So in diesel engine, sufficient amount of air we are supplying, and due to that the carbon monoxide emission and hydrocarbon emission will be lesser in diesel engine as compared to petrol engine. In petrol engine, the hydrocarbon emission and carbon monoxide emission will be higher. Okay, so I hope, guys, you got the idea what is that NOx formation. So NOx is nothing but a kind of reaction. NOx, nitrous oxide, is going to form when nitrogen and oxygen are going to react. So why actually I am writing it as NOx only? Because you can get NO2 also, you can get NO also, you can get NO3 also. Okay, it depends. Okay, so that's why we generally write it as NOx, nitrous oxide formation. They are going to get when there is a nitrogen and excess of air, they are combining at very high temperature. Usually the temperature required in the range of 1380, 1480 degrees Celsius. So if that much high temperature is there in the engine, close to 1400 degrees Celsius, then nitrogen, oxygen, they are going to combine and they are going to form nitrous oxide. Fine, guys. So I hope these three type of three, four types of these primary pollutant emissions are very much clear to you. Some more things we are going to discuss, don't worry. The main cause of emissions for IC engine, I think these things we already had discussion. Chaliye next. Spark ignition engine emission. So guys, in SI engine, what are the various sources? SI engine is a source, petrol engine is source, but in SI engine also what are the various points where we are going to observe the emission? So guys, first the exhaust emission. Exhaust emission, guys, means the emission, the pollutants which are coming out through the exhaust gases like carbon monoxide, hydrocarbon, NOx, and lead. Okay, in petrol engine, nowadays this is banned. We don't add tetramethyl lead in the petrol engine. Usually there was practice initially to add this lead into the petrol to increase its octane number, but this is banned nowadays because lead, if it is entering into the air, that is also going to cause pollution. Okay, so this is banned now. Nowadays you cannot add tetramethyl lead into the petrol, but yes, if you are adding tetramethyl lead into the petrol, that is going to increase the octane number, the quality of the fuel is going to improve. Okay, but yes, that is going to cause the pollution. So in general, petrol engine mein exhaust product mein you can get carbon monoxide, hydrogen, NOx, and lead. Okay, these are the pollutants which you are going to get from the exhaust gases. Similarly, from the fuel tank, you can get some kind of evaporative emission of what? Hydrocarbon, because the petrol is a very volatile substance, so it is going to evaporate from the fuel tank when you are opening the tank for filling or for other purposes, suppose, and even some kind of air vent also we keep to maintain some pressure. So hydrocarbon are going to evaporate from the tank. Also from the pipeline also, You can check it here. So evaporative emissions from the pipeline, suction pipeline, okay, crank, you can observe it here, crankcase emission. Okay, so when you are supplying these charge, okay, these charge, the mixtures are they are entering. So this is what the entry kind of evaporative emission pipeline. Okay, so the direction will be something like this, guys. So this is the inlet and this is the exhaust. So this is inlet valve, this is exhaust valve, something like this. So the arrow I am correcting, guys. So from tank, this is going through the evaporator. This is a kind of what you can say carburetor you are having. So from tank, the fuel and air, they are going into the carburetor. So carburetor, through carburetor we are going to get the air fuel mixture, okay, into the combustion cylinder. Then after combustion, the exhaust product, they will go through the exhaust valve, something like this. So guys, you know, sometime what happens in IC engine, you know, we use very high compression ratio. In petrol engine we use compression ratio in the range of 8 to 10. In diesel engine we use compression ratio in the range of 16 to 20. So due to that, very high pressure temperature is there. So although we keep some kind of seal between the cylinder and piston by providing some piston rings, but as the time passes, due to the wear and tear and due to very high pressure here in the combustion cylinder, some hydrocarbon they leaked out into the crankcase. Okay, so some hydrocarbon they leaked out and they go into the crankcase. So this lower part of the engine, which actually known as crankcase, okay, because this part of the engine, this is known as crank, guys. That much detail is not required for you. This is piston, this is connecting rod, this is crank, and this is known as crankshaft. So the lower part, which is a kind of casing for the crankshaft, that is known as crankcase. So this particular area is known as crankcase, guys, and in this particular area, the lubricant is present. So when those hydrocarbon they are leaking out due to the wear tear or due to the very high pressure into the combustion cylinder, those hydrocarbon they are leaking. The mixture of air and fuel they are leaking into the crankcase. That is known as crankcase emission. Guys, when they are going to leak into the crankcase, two major effects we can get. One, if there is, you know, very high concentration hydrocarbon are leaking out into the crankcase, then some kind of crankcase explosion can occur. Explosion can occur in the crankcase. If huge amount of hydrocarbons are leaking into the crankcase, they can combust in crankcase. That is known as crankcase explosion. Otherwise, when hydrocarbon are entering into the crankcase, they are going to dilute the lubricant. They are going to mix with the lubricant, okay, and they are going to dilute it. So that is also a kind of effect which we are going to observe majorly due to the blow-by. This is known as engine blow-by, guys, because these gases, hydrocarbons and other exhaust gases also, exhaust gases or hydrocarbons, they are leaking into the crankcase. That is known as engine blow-by. It is a kind of loss. Fine. So engine crankcase, the losses in the intake manifold, the losses in the tank. Okay, so these kind of you know, these are the main sources present in the SI engine. Other than exhaust pipe, the losses, the pollutant emissions we can observe in crankcase as well as in tank and in the main pipeline. Fine, guys. So I hope this is clear. What are the major sources of pollutants coming out from SI engine? Now guys, let us talk about SI engine emission control. How we can control the emission in case of SI engine. Although we are going to discuss this topic in very detailed manner, we are going to discuss some topic related to catalytic converter, okay, which we use nowadays in our engines to reduce the pollutants. So guys, in SI engine, if you want to carry out the emission control, you can carry out some kind of modification in the SI engine. Modification in terms of what? You can design engine so that there will be very good turbulence, so that air fuel mixture will be good. Each and every fuel particle will get sufficient air. So first, there is a requirement of designing the engine in a very accurate manner. Okay, the combustion chamber design, the overall engine cylinder design. Also, there is a one term, surface area to volume ratio. This is also, you know, to keep it lesser. S by V ratio. So if S by V ratio is lesser, then also the kind of combustion products emission will be lesser. Okay, because if surface to volume ratio is higher, then obviously the coolant losses, the heat transfer losses will be higher, and due to that, the fuel particle, when they will be injected through some nozzle, they will reach to some wall. That is a kind known as kind of quenching. So they will due to the heat transfer, they will not be able to vaporize quickly and they will remain as a droplet only, they will remain as a liquid only. That's why the hydrocarbon emission into the exhaust product is going to increase. That's why it is good to keep S by V ratio lesser. Okay, there are some more terms like the kind of squeeze area. It is good to keep that squeeze area lesser. Quench area or squeeze area, those are kind of similar term. So I'm not going to that much detail because that is not required. So what you need to understand, by properly designing the engine, by decreasing the squeeze area, quench area, by decreasing the surface to volume ratio, by enhancing the turbulence inside the engine, or if you are designing the engine like that so that there will be good turbulence, you are providing some turbocharge or supercharge in the engine. So by modifying the engine design or operating parameter, we can reduce the emission. Second, treating of the exhaust product. So in this case, we are going to talk about the catalytic converter. So catalytic converter is a device which is not going to reduce the pollutants, it is going to treat the pollutants which are coming out into the exhaust gases. So catalytic converter is not going to reduce these. By using, by improving these operating parameters or design of the engine, we will be able to reduce the pollutants. But there are further, after even optimizing these parameters also, you are going to observe some pollutants into the exhaust gases, and then you need to treat those pollutants. So some kind of treatment of the exhaust product you can carry out to reduce those pollutants. So that may be a kind of burner you can attach into the if you want to carry out the burning of the hydrocarbon which are going into the exhaust gases, carbon monoxide. So some kind of oxidation you can carry out by attaching a kind of burner into the exhaust product. Okay, so exhaust gases burning you can carry out by passing them through the afterburner, kind of that thing, but that is not in practice nowadays. We are using nowadays what? Catalytic converter. So in separate discussion we will have related to catalytic converter. Third, you can use some kind of good fuels. You can use a petrol fuel with very high octane number. You can use biofuels, you can use alcohols, you can use methanol. Okay, so methanol, ethanol and other kind of biofuels, they are the good options, guys, because they are not going to cause that much pollution like CNG, LPG. So those pollutant emissions is lesser as compared to petrol and diesel in case of those kind of fuel. So if you are modifying the fuel or if you are replacing the fuel, like suppose you are using hydrogen as a fuel in heat engine. So in IC engine you are operating on hydrogen, there will be no emission, guys, because in exhaust product you are going to get water vapor only. So hydrogen gas, when it is going to burn, it is going to combust by taking oxygen. In exhaust product you are going to get the water vapor only, and when water vapor is entering into the air, it is totally safe, guys. So there will be no pollutant emission. That's why people nowadays, they are talking about the hydrogen engines, they are talking about the e-vehicles, battery operated engines, they are talking about the methanol based engines, they are talking about the ethanol based engines, something like that. So by improving the fuel, you can reduce the engine emission. Chaliye, now let us have some basic difference. What kind of emission is prominent in petrol engine, what kind of emission is prominent in diesel engine? So guys, if you talk about lead is a kind of anti-knock compound which improves the octane number of the petrol. So this is a very kind of major contribution in SI engine. Lead pollution is not there in diesel. Lead pollution will be there in petrol, because lead usually we add in petrol to improve its anti-knocking tendency, and that anti-knocking tendency is nothing but known as octane number. More is the octane number, more is the anti-knocking tendency. Okay, so similarly carcinogens, these are there in diesel exhaust. Okay, diesel exhaust में आपको मिलते हैं, and they are also the major contributors in diesel engine. Similarly, if you talk about acid rain, which takes place due to the sulfur dioxide, oxygen, oxides of nitrogen, unburnt hydrocarbon and carbon monoxide. Guys, this time we had a discussion about these only. Acid rain, global warming, photochemical smoke, ozone depletion. Separately, we will have discussion related to this. Actually, I segregated this entire discussion related to pollution from IC engine into three parts. First, the pollutants from IC engine. Second, the emission control, majorly the discussion about the catalytic converter, and in third class we will have discussion about the environmental impact. What is that acid rain? What is that photochemical smoke? What is that acid rain and this ozone depletion? So what kind of environmental impact we are getting due to these pollutants which are coming out from IC engine? That will be our topic of discussion in the third lecture. First lecture is going on. Second, we will have discussion related to catalytic converter. Third, the environmental impact. Fine. So only you need to observe this CFCs. Okay, these are not related to IC engine pollution, guys. Chlorofluorocarbon. Okay, these can be released from the car AC. Okay, because these are a kind of refrigerants, chlorofluororefrigerants banned nowadays. Carbon dioxide, methane emission, B means, A means the major contributor, A is representing here the major contributor, B is representing the secondary influence. So means influence is there but not primary contributor. Okay, but A is representing the major contributor or a kind of primary contributor. Ozone depletion, okay, which majorly it is due to the CFCs, unburnt hydrocarbon, carbon dioxide is going to cause the global warming. Okay, you can check it here. Chaliye, so just observe this. Fine, let us move to next discussion. Commercial vehicle control, emission control, commercial, this passenger car diesel engine emission control. Again, we had some discussion, you need not to go into much more detail, but some basic idea you need to have how we can reduce the diesel emission, passenger car diesel emission. So you can check it here, some kind of indirect injection technique you can use. Okay, nowadays we are using TDI technology, turbo direct injection system. We are using multi-point fuel injection system. Okay, earlier there was some kind of port injection systems were there. Okay, but yes, as the technology is improving, we are carrying out improvement into the injection system. We are injecting the fuel in diesel at a very high pressure. Okay, I hope you know about the common rail direct injection system, CRDI technology, common rail direct injection system, common rail diesel injection also sometimes we mention it like that, but it is common rail direct injection system which we use in diesel engine. Okay, so by using those kind of technology, we can reduce the engine emission, complete combustion of injected fuel, minimum lube consumption, retarded combustion, moderate air motion, particulate emission control is helped by high injection pressure, fine fuel atomization, high excess air, minimum lube consumption. So guys, the main point is what? By improving the kind of injection system, by improving the engine design, by improving the quality of fuel, okay, you can decrease the emission from IC engine. Similarly, you can observe it here, the commercial vehicle emission control, improved in fuel injection, common rail, CRDI technology we can use, electronic control we can provide. Okay, because as compared to mechanical control, electronic controls are much more accurate and reliable. So you can go with the this electronic control system that is there nowadays in all the vehicles. Good dynamic response to engine load, speed and temperature. Okay, so if you are maintaining these things, we will be able to reduce the emission in SI engine. Okay, now guys, this chart is very important because this is showing us the difference in emission in petrol and diesel engine. Okay, although the carbon monoxide emission, hydrocarbon emission, NOx, odor or smoke, all these kind of emissions we are going to observe in petrol engine, gasoline means petrol, and diesel engine also, but their percentage are different. So carbon monoxide emission, this dotted line, this is representing what? Gasoline, petrol. So you can check it here, the carbon monoxide emission is much higher in petrol, hydrocarbon emission is much higher in petrol. So carbon monoxide emission is very lesser in diesel, hydrocarbon emission is lesser in diesel. Why? Due to the excess air present in the diesel engine. Okay, whereas NOx emission is almost comparable, slightly more in diesel engine. But if you talk about the smoke, if you talk about particulate matter pollution, guys, you know, in diesel is not a refined fuel. Petrol is more costly because it is a very much refined fuel. Diesel engine is not a refined fuel. Okay, so in diesel there are so many substances present. So when you carried out the combustion of diesel, sometime due to the incomplete combustion or due to some kind of conditions inside the engine, some kind of aldehyde formation takes place, and those aldehydes, when they are suppose not getting sufficient air, so they are going in the exhaust products like that only. So further the combustion of aldehydes, if it is not taking place, although if those aldehydes are getting the sufficient air, then you can have the combustion of aldehydes also. But suppose if those aldehydes are not combusting, they are not getting excess air, sufficient air, okay, or they are not combusting. Okay, so initially some aldehyde formation will be there, so you will have some aldehyde products as a product, intermediate product, that will be right to say, because those are not the final product. But those intermediate product, suppose if they are not further burning, so then those aldehydes will be there in the exhaust product. That's why very kind of pungent smell, odor we are going to get in case of diesel engine. So that's why the odor, okay, we are nowadays talking about treating this also, but the catalytic converters which we are having in ICE engine, those are not capable actually to deal with that odor. Okay, but yes, we are talking about this, and yes, soon some technology will come so that we will able to deal with this also. So odor and smoke problem. Smoke means, you know, the carbon particle which is there in the engine, suppose that is also a kind of present, a kind of substance present in the all hydrocarbons. So if that carbon is not getting the sufficient air and that carbon is going into the exhaust product, so you are going to get very dark smoke. So dark smoke, if you are observing, that is also a kind of pollution, because those unburnt carbon particle, okay, you can have a kind of two type of smoke. It may be bluish white or dark smoke. So bluish white smoke you are going to get when you are carrying out the some kind of combustion of the lubricant. So some lubricant, if it is there into the combustion chamber, suppose that is mixing with the combustion product, so you are going to get some kind of bluish white smoke in case of diesel engine. So bluish white smoke in diesel engine represents the combustion of the lubricant. Similarly, the dark smoke in case of diesel engine represents the combustion of the unburnt combustion of the carbon product. So carbon particle, if they are present in the exhaust gas, you are going to get the dark smoke. So the dark smoke odor will be much higher in diesel. Particulate matter, okay, when we talk about PMM10, PMM2, because those are the particulate matter present. Okay, you know guys, when you some kind of, you know, particles, when you are carrying out the combustion, so some intermediate products you are getting. So those intermediate products, if they are not burning, those intermediate products, they will go into the exhaust gases and as a kind of particle only. So that is known as a particulate matter pollution, because those are very fine particle, guys. Particulate matter, they are very, very fine. Okay, their sizes are very less. So when someone is inhaling those kind of particulate matter, that is going to affect his lungs also and other parts also. Okay, so that is also a kind of major pollution. The particulate matter pollution which is there in the smoke of diesel engine is much higher, okay, as compared to the smoke or particulate matter pollution which is there in the petrol engine. So smoke pollution, odor pollution is much higher in diesel. NOx is also much higher, almost comparable in petrol, diesel, but hydrocarbon emission and carbon monoxide emission is much lesser in diesel engine as compared to petrol engine. Now let us talk about in some percentage. So guys, if you consider the exhaust product of diesel and exhaust of gasoline, petrol, you are going to observe majorly nitrogen, 70, 74, 75% nitrogen, then close to 10% oxygen. Now if you check it here in diesel, because in diesel we supply excess air, that's why even in exhaust product you are going to get 10% oxygen, but here in exhaust product you are having very less oxygen. Why? Because in petrol engine we don't carry out any kind of supercharging, turbocharging, because if you are carrying out supercharging, turbocharging in petrol engine, that is going to increase the knocking tendency. So we cannot carry out this supercharging, turbocharging in petrol engine. That's why the amount of oxygen which is there in the exhaust product in case of petrol engine is very less. Water 7%, here 13%. Carbon dioxide emission is 7%, here the carbon dioxide emission is 13%. Other emissions are less than 5%, and here also they are less than 5%, but their, you know, further percentage varies. Like here in this emission we are talking about what? Carbon monoxide emission, we are talking about hydrocarbon emission, we are talking about NOx, we are talking about sulfur oxides. Okay, so these are the emissions. Okay, so total percentage of the emissions will be, pollutants will be less than 5%, whether it is a case of petrol engine or diesel engine. Fine. Further, if you want some exact percentage, although it is not required, but you can observe it here. Out of that total less than 5%, if you want to check the percentage of NOx, this is a kind of composition of exhaust gases from SI engine, and this is representing composition of exhaust gases from CI engine. So you can check it here. The percentage of NOx close to 0.08%, percentage of hydrocarbon 0.05%, percentage of carbon monoxide, okay, this sulfur oxide and other particulate solids. But here if you check this particulate solids which is less than 0.005%, and here the particulate solids in case of diesel engine are much higher. Here the percentage of particulate solids, the particulate matter, very fine particle which are going into the exhaust product, those are known as particulate matter. So here the percentage is much higher, 0.15%. But If you check it here, the percentage of CO is lesser. Here it is 0.85%. Here it is 0.45%. The percentage of hydrocarbon here it is 0.05%. Here it is 0.03%. NOx will be almost same. Okay. Fine, but slightly higher in diesel. NOx emission is slightly higher in diesel. Okay, so it is a kind of chart, pie chart we are having, which is showing us further the percentage of various pollutants which are coming out from SI and CI engine. So guys, in today's class, majorly we had a discussion related to the different fuels, different pollutants which we are getting from SI engine, CI engine. Next class we will have discussion related to the treatment of the pollution, the emission, exhaust emission which we are getting from IC and CI engine. Okay, SI and CI engine. Third class we will focus on the environmental impact like acid rain, the photochemical smoke, the ozone ozone depletion and greenhouse effect. Okay, so in that those topics we will discuss in the third class. So I hope some basic things are very much clear to you. What are the different pollutants and what are their further difference, pollutants which are coming out from SI engine, pollutants which are coming out from CI engine. So you can refer to this also just to have some idea about the various pollutants which are coming out from SI and CI engine. Okay, chale guys, again we will meet and we will have some more discussion related to the air pollution which is caused by IC engine. Thank you. Please keep revising. Again we will meet. Good luck. Have a nice day.